time. So just play a video which is already all gone through. Just it will complete within 10 minutes. You just have a look on that. Before entering into the video, let me confirm whether voice is audible to all. Exam is very important. Okay. Okay, it's not supporting. The video is not playing. I don't know whether the network is so poor. Yeah, it's too much of problem. Video under YouTube, it's not playing, it's not supporting. Okay, fine. Within 10 minutes, I'll just go through the first lesson because here and there some questions may arise. And definitely I won't do in the class. And you just chemical reactions and equations is chemical equations are symbolic representation of chemical reaction. And chemical reaction is one which result in change in color, state, and evolution of gas and change in temperature. This is known as chemical change, and if it is represented in a symbolic form, then it is called chemical equation. If the number of atoms at reactant side is equal to the product side, then it is called balanced chemical equation. When the metal like iron reacts with water, it forms ferric oxide with the release of hydrogen gas. This is one of the example for corrosion also, which is there in metals and non-metal. And that chapter is compulsory for your exam. And please, you all note this equation which is given in page number 5. Iron reacts with water to form ferric oxide with the release of hydrogen. This is called rusting. And how it can be prevented? How the rusting can be prevented? You all know that. Okay. And usually when we observe some of the equations, chemical equations, which occurs naturally. In village side, we used to observe whitewash, that is also chemical reaction. When we eat the food, that converts into glucose, that is also chemical reaction. And again, glucose in presence of oxygen, it breaks down to release carbon. Even that is when on the road, it undergo combustion, that is the petrol fuel undergo combustion to release carbon dioxide and water vapor. Even that is also chemical reaction. So many in our life we come across chemical reactions. Example, our milk converts into curds, that is also a chemical reaction. The gas, when we burn LPG gas, even that is also chemical reaction. So many reactions we come across in the nature. Now let we know few examples on this. First one is chemical combination. We all know that the quicklime, when it reacts with water, it forms calcium hydroxide, and that is the equation used in whitewashing. And this is a best example for combination. What is combination? When two or more reactants combine together to form one product, then it is called chemical combination. The other examples are carbon reacts with oxygen to form carbon dioxide, hydrogen reacts with oxygen to form water, methane combines with oxygen to form carbon dioxide and water. This is exothermic reaction. This is called exothermic reaction. The glucose in presence of oxygen breaks down to release carbon dioxide and water with energy. This is also exothermic reaction. Then what is exothermic reaction? Any chemical reaction where the heat is evolved is known as exothermic reaction. And one more, endothermic reaction. Endothermic reaction is one where heat is absorbed. Where the heat is absorbed is known as endothermic reaction. Now, let me go with another type, decomposition reaction. Decomposition reaction is one where one reactant breaks down to form two or more simple products. One reactant breaks down to form two or more simple products is known as decomposition reaction. Example, ferrous sulfate, when it is heated, it results in ferric oxide plus sulfur dioxide and plus sulfur trioxide. In the same way, when limestone, that is calcium carbonate, when it is heated, it results in calcium oxide plus carbon dioxide. These are the example for decomposition. And these are the example for thermal decomposition. We are heating. And silver chloride, when it is kept in sunlight, it converts into silver and chlorine gas is escaped. And this is known as photochemical decomposition. In electrolysis of water, the water breaks down to hydrogen gas and oxygen gas in presence of electricity, and this is called electric decomposition. So decomposition are three types, that is thermal, electric decomposition, photolytic decomposition. And next reaction, you can have a look here, page number 11. 11, you just mark it. It will be useful. Again, it repeats in metals and non-metals chapter. It is in metals and non-metals. You note these two pages. Okay, and of the things you need not to. Blue color solution converts into pale color. This is because of formation of iron sulfate and copper gets separated. Why this happens? This happens because highly reactive metal displaces less reactive metal. Iron is more reactive than the copper, hence displacement. Okay, so much of problem. I didn't see the messages. You are not able to hear me. Okay, I have 3 points. In the morning also I had same network. Yeah, sometimes breaking is okay, but others they are saying continuous breaking of the voice. How come? The network is same as morning, but you all know that Sunday, now it's very busy. Okay, I think it will be rectified because I'm not sharing the screen. I thought of sharing the screen. I have images on metals, non-metals, acid, bases and salts, carbon and its compound. I have. Okay, but I hope it will be rectified. Okay. And again, I want to take physics. Okay, at any cost, I should complete chemistry right now because at 5 I want to complete physics. Okay, I'll move on. The next concept is displacement reaction, where the highly reactive metal replaces less reactive metal, and thus it leads to the displacement. And there is double displacement reaction, where the insoluble substance like precipitation is formed, and double displacement is also called as precipitation reaction, where in double displacement there is an exchange of ions between the reactants. There is exchange of ions between the reactants, and it is called double displacement reaction. And there is oxidation and reduction, when in any chemical reaction addition of oxygen or removal of hydrogen takes place, then it is called oxidation. Example, copper plus oxygen, copper oxide. This is called oxidation. The other one is reduction. When copper oxide added with hydrogen, it results in copper and water. This is the example for reduction, and also example for redox, where copper oxide is reduced to copper, that is removal of oxygen. Hydrogen is oxidized to water, addition of oxygen, and hence such reactions are called redox reactions. And the final concept in the first chapter is corrosion. Sometimes the metals are eaten away by the activity of acid, salts, water, oxygen, etc., and thus it results in a great damage of car bodies, bridges, iron railings, ships, etc. Okay, let me see for another few minutes. Let me see for another few minutes. It will be rectified, because if I quit now, I won't get time to complete anodizing, electroplating, chrome plating, etc. Now, iron oxidation of fat or oil present in the food materials is called rancidity, and this can be as oxidants. And even potato chips bag is filled with nitrogen gas to prevent rancidity. So this completes the first chapter. Okay, anyone is hearing clearly? I just completed first lesson. Anybody heard clearly? If it is there, so my network is okay and your plus it's weak. Okay, Vandana, what Vandana? Did you heard first lesson revision, or you had any problem? Gangotri, did you heard clearly? Yeah, Aishwarya, are you hearing me? Okay, fine. Kalpana is having no problem, and only few people are having the problem because in your place there is no network, and that have same network as morning. No variation. Morning too I had same network. Now too. Okay, we'll move on to acid, bases, and salts. Anyhow, I thought of sharing the screen, but right now I can't share the screen because when I share the screen, you all miss the voice. And many food items are rich with bases, and obviously without salt. Thus, acids can be identified. How the bases are identified? Bases are identified as they are bitter in taste and they changes red litmus to blue. And obviously, the salts are somewhat precipitated compounds and exist in crystal form, usually used in different way. And how the acids reacts with metals? When acids reacts with metal, like dilute acids, it forms salt and hydrogen gas. Example, when sulfuric acid, dilute sulfuric acid is reacted with zinc granules, it forms zinc sulfate and hydrogen gas. This is the example for how acids reacts with metals. And how the metal carbonates and metal hydrogen carbonates reacts with acids. Sodium carbonate and sodium bicarbonate reacts with hydrochloric acid to form salt, water and carbon dioxide. So this is how the carbonates and hydrocarbonates releases salt, water, along with that carbon dioxide is released. And how the acids and bases are reacted with each other? They react with each other to form salt and water. Even when metal oxides reacts with acid, they too form salt and water. And even there is one more example, non-metallic oxides reacts with base to form salt and water. In any chemical reaction where the salt and water are formed, such reactions are called what? Okay, give me the answer. Such reactions are called as what reactions are called as? Yeah, Priyanka answered correctly. It is neutralization. Okay, when the questions arise in this manner, salt and water, you try to check how many are there with the neutralization. Is there any similarity or not? You check and then you go with the answer. Okay, don't lose the marks. These are easier questions. Connected with electric current in an aqueous state, definitely they'll conduct electricity. And how they conduct electricity? In aqueous state, all acids undergo decomposition into ions. They decompose to form ions, and ions are free enough to move in the solution and they conduct electricity. And in acid and bases, very important concept is pH. We all know that 0 to 7 it is acid, where H plus ion concentration is more, and 7 to 14 it is base, where OH minus ion concentration is high. Even with the colors, the questions may ask with the colors. If it is red to yellow, then it is the strong acid to weak acid. If it is purple to green, strong I posed a question. If it is from red to yellow, strong acid to weak acid. Yellow is weak acid. If it is purple to blue or bottle green, then strong base to weak base. If it is green, what does it indicate? Yes, that indicates neutral. Keep the answer correctly. 7, if it is green in color, then that indicates neutral. Remember, the questions may ask here, the pure water and blood, they are neutral. For weak base, milk of magnesia, it is a weak base. Sodium hydroxide is a strong base. It is a strong base. And gastric juice is a strong acid. And lemon juice little bit lower than the gastric juice. So pH plays a very important role in our daily life. The pH from 7 to 7.8. Remember, 7 to 7.8 is very essential for survival of living. How the pH plays in our daily life. In case pH less than 5.6, acid rain, and that acid rain enters into water bodies, changes the pH of the soil and the water. Thus, it affects the survival of aquatic life and also vegetation grown in that particular soil. Now, before entering into agriculture, knowing the pH of the soil is very important. Why it is very important? By knowing the pH, we can grow, we can select the crop. Without any knowledge of pH, if we reverse the crop, definitely the farmer won't get any yield. So, it is always better to know the pH, and as per the pH, growing the crop is very, very important. Now, pH in our digestive system. We all know that HCl, a digestive gastric juice, HCl, plays an important role in digestion. Only in acidic medium, the pepsin and renin get activated. So, HCl, that is lower pH, is very important to activate pepsin and renin. In turn, it helps in digestion. And what is the pH importance in tooth decay? We all know that the pH of our tooth in the morning, it will be very less, because when we eat the food and after that without brushing, if we sleep, the food particles which are sticking to our teeth will give the chance to develop bacteria, and the bacteria produces lactic acid, and thus it degrades the teeth. In order to bring it neutralize, what we have to use? We have to use paste, toothpaste. The paste present which brings neutralization. Hydroxide, that is an antacid. Magnesium hydroxide or milk of magnesia brings neutralization in our stomach. And even honeybee, which secretes methanoic acid to protect themselves, ants produces formic acid to protect themselves, and even the nettle leaf produces methanoic acid to protect themselves. And where there is a nettle leaf, there will be dock plant, DOCK, dock plant. And dock plant produces bases. Soon after the bite of nettle leaf, if you place a dock plant juice on that, definitely it will bring neutralization. So this about acid and bases, its pH role in our daily life. Other than this, there are different kinds of salts. That is, by using the brine solution, we can get chlorine, hydrogen, and sodium hydroxide. These three has its own importance, and sodium hydroxide is called as caustic soda. The name of caustic soda is sodium hydroxide. We all know that chlorine helps in water treatment, swimming pool cleaning, PVC pipes, manufacturing, disinfectants, CFCs. And hydrogen is used as fuel, margarine, ammonia for making fertilizers. And sodium hydroxide is mainly used in degreasing the metals, soaps and detergent manufacturing, paper making, and also in making artificial fibers. Okay, next concept is bleaching powder. Bleaching powder CaOCl2 is the molecular formula, and bleaching powder mainly used in bleaching the cotton, linen, and it is used as oxidizing agent, and it turns used in making baking powder, and it is used as extinguishers. These are the uses of baking soda. And the next one is washing soda. So washing soda is calcium chloride, hydrated sodium carbonate. Hydrated sodium carbonate is called as washing soda. And what are the importance of washing soda? The sodium carbonate, hydrated sodium carbonate is used in manufacturing glass, soap and paper industry. It is used in manufacturing sodium compounds like borax. Sodium carbonate is mainly used in cleaning agent, and it is used for removing permanent hardness of water. These are some of the uses of washing soda. And there is one more thing, that is gypsum. Gypsum is used in manufacturing calcium sulfate. CaSO4, two molecules of water, is gypsum. And when heating the gypsum, we'll get hemihydrate calcium sulfate. On heating gypsum, we'll get hemihydrate calcium sulfate, that is CaSO4 dot half molecule of water, that is hemihydrate calcium sulfate. This is plaster of Paris. And what is the importance of plaster of Paris? It is mainly used in making toys, and it is used for decoration purpose, making the surfaces smooth, and also used in hospitals in setting up the bone fractures. So this completes acid, bases and salts. metals and non-metals. Quit now. I want to go with physics also, right? Okay, shall I move on to the metals and non-metals chapter? Because I'm not sharing the screen and many of y'all may have the problem. I just go with the concepts which are very important. Shall I move on to the metals and non-metals? Okay, fine. At least few were able to hear clearly, I think so. Okay, we'll move on to the metals and non-metals. We all know that metals and non-metals plays very important role in our daily life, and there are many important physical and chemical properties in order to identify the metals and non-metals. When you look at the periodic table, towards the left it is maximum covered by the metals, towards the right it is covered by very few non-metals and halogens and noble gases. Okay, and what are the important properties of metals and non-metals? Metals are sonorous, whereas non-metals are non-sonorous. Metals are malleable and ductile, whereas non-metals, they doesn't show this property. Metals are good conductors of heat and electricity, whereas non-metals doesn't show this property except graphite, which shows conductivity with electricity. And metals are having high boiling point, melting point, where non-metals have less boiling point and melting point. And metals exist in solid state except gallium and mercury, whereas non-metals exist in solid, liquid and gaseous state. This is about the physical properties, and when we move on to the chemical properties, all metals reacts with oxygen to form metal oxide. Example, copper reacts with oxygen to form copper oxide. Aluminium reacts with oxygen to form aluminium oxide. Zinc reacts with oxygen to form zinc oxide. Among these three examples, copper oxide is a corrosion, whereas aluminium oxide and zinc oxide, these are amphoteric oxides. Why it is called amphoteric oxides? These metal oxides reacts with acids and bases to produce salt and water. Hence it is called amphoteric oxides. Okay, this is very important. These two examples, that is aluminium oxide and zinc oxide, are called amphoteric oxides. And another chemical property is when the metals reacts with water, sometimes it forms metal oxide with hydrogen and sometimes it forms metal hydroxide with hydrogen. Example, when calcium reacts with water, it forms calcium hydroxide plus hydrogen gas. In the same way, aluminium reacts with water to form aluminium oxide with hydrogen. Iron reacts with water to form ferric oxide plus hydrogen. So this is another chemical reactivity among metals and water. And what happens when metals reacts with acids? When metals reacts with acids, obviously dilute acids, we all know that they form respective salt and hydrogen. It forms respective salt and hydrogen. And next concept is when metals reacts with other metals, what happens? It leads to displacement reaction. And in the displacement reaction, I already told it is given in first chapter also. In displacement reaction, highly reactive metal replaces less reactive metal. High reactive metal replaces less reactive metal. This is called displacement reaction. And as per reactivity series, we all know that potassium is most reactive metal. Gold is less reactive metal. If they have given platinum or silver, when metals reacts with non-metals, they form ionic compounds. How ionic compounds are formed? By forming the ions. And between the ions, there will be ionic bond. And thus, ionic compounds are formed. What are the important, what is an example for ionic compound? Sodium chloride, magnesium chloride. These are the example for ionic compounds. What are the properties of ionic compounds? Ionic compounds are solids, but they show brittle nature. They have high melting point and boiling point. And they are easily soluble in water but insoluble in kerosene and petrol. And they are good conductors of electricity only in molten state. But they are bad conductors in solid state. How they conduct electricity in molten state? The ionic compounds converts into ions, and the free ions can move easily and they can conduct electricity. And this is about chemical reactions between metals and non-metals, between metals with other components. Now, let me go with more information on metal extraction. The extraction of metals in a very furnished way is known as metallurgy. Earthen impurities. And how we can extract the metals and metal by separating the impurities is known as concentration of ore. The concentration of ore is with three methods, that is metals of high reactivity, metals of medium reactivity and metals of low reactivity. The metals of high reactivity is done with electrolysis. Metals of medium reactivity is done with calcination and roasting. The metals of low reactivity is done with roasting, just by roasting. Let me go with an example how the metals of low reactivity can be extracted. Example, cinnabar. What is cinnabar? Ore of mercury is called cinnabar. And how the cinnabar is purified, from which mercury can separate it? By roasting. When mercuric sulfide is roasted in excess of oxygen, it forms mercuric oxide. Mercuric oxide on reduction, it converts into mercury and pure mercury is obtained. In the same way, copper sulfide, copper oxide, they undergo roasting to form copper. Copper sulfide is a ore which commonly called as chalcocite. And extracted which are showing medium reactivity, that is zinc sulfide, zinc carbonate. Example, you just remember zinc sulfide, zinc carbonate are medium reactive ores on the roast zinc reduction. The zinc oxide on reduction, it converts into pure zinc. And even sometimes when the iron oxide with aluminium, in a molten state used to join railway tracks or cracked machine parts, and this is known as thermite reaction. Remember, iron oxide with aluminium in molten state used to join railway tracks or cracked machine parts, and this process is known as thermite reaction. And how the metals of highly reactive series can be extracted. reactive metals, sodium, potassium, can be extracted by electrolysis. Not only sodium and potassium, aluminium, copper, gold, even they can be extracted by electrolysis, because aluminium is more reactive with the oxygen, hence roasting is not possible. It is not a carbonate, hence calcination is not possible. Only electrolysis can be easy to extract aluminium. Remember, aluminium is more very attractive towards the oxygen, hence we cannot adopt roasting or calcination. So electrolysis is adopted. And electrolysis, you all know that cathode and anode plates are immersed in metallic oxide, and anode is made up of ore with metal and impurities, and cathode is made up of pure metal. Now when electric current is passed from the anode, all the metals starts moving towards the cathode, and impurities, mud and earthen impurities, just collected at the base of the anode as a anode mud. And this is how the pure metals are deposited on cathode. We all know that some metals are eaten away by the activity of acid, base, salt, air, and that can be galvanizing, chrome plating, electroplating, etc. And some of the examples for corrosion we already quoted in the first chapter. Iron reacts with water to form ferric oxide with hydrogen, that is called rust. Copper reacts with carbon dioxide to form copper carbonate, which is a green coat. Iron reacts with water to form a brownish powder called rust. Remember, silver reacts with sulfur to form silver sulfide, which is black color. Copper reacts with carbon dioxide to form copper carbonate, which is green color. Iron reacts with water to form brown rust. And definitely the questions will arise from these 3 points, definitely. And prevention, I already told, it is by galvanizing, greasing. Okay, this completes metals and non-metals chapter. By this, we completed first semester chemistry, and 2 more lessons are there in second semester book. Shall I continue? If you don't have any objection, I'll finish off. That is Carbonates Compound periodic table. If you don't have any objection, I'll continue. Okay, Revati, you don't have any problem, right? You can hear me? Now those who are replying, can you all hear me clearly? Because tomorrow you all having the exam, so I'm taking so much of risk. Still I don't have any food. I didn't had a bath. I'm sitting because of y'all. Okay, because tomorrow is exam, that is the reason. Okay. Okay, fine. We'll move with the carbonates compound very soon. Within half an hour, I'll complete this, so that at 5 o'clock let we have physics concepts. Okay. Now carbon and its compound. We all know that carbon is tetravalent inorganic compound, belongs to 14th group, and it is a very unique element, and in the atmosphere it is 0.03% available in a form called carbon dioxide. On the crust it is about 0.02% of carbon in a form of carbonates, hydrocarbonates, coal, petrol. And it is a unique element whose electronic configuration is 1s2, 2s2, 2p2. Atomic number is 6, belongs to 14th group, and it is a tetravalent, and it shows both C minus 4, C plus 4. It can act as an anion and it can act as cation. Okay, it is ready to donate electron and ready to receive electron. Okay, and we all know that carbon undergo forming covalent bonds with other elements. Why? It is sharing of electrons. Covalent bond means it is sharing of electrons. There is no ion formation. It is sharing of electrons. I'll give an example. Carbon is a non-metal. Hydrogen is a non-metal. Between hydrogen and carbon, covalent bond is formed by sharing the electrons, and it is usually between non-metal and another non-metal. Thus hydrocarbons are formed. When carbon combines with hydrogen, hydrocarbons are formed, and that is formation of covalent bond. And how ionic bond is formed? It is formed between metal and non-metal. But here hydrogen molecule, you just take hydrogen molecule, both are non-metal, H2, right? It is also covalent bond. O2, it is also covalent bond. N2, even it is also covalent bond. But the thing is, between hydrogen it is single bond. Between oxygen it is double bond. Between hydrogen it is triple bond. Okay. Now let me study in deep what are hydrocarbons. The carbon undergo covalent bond with hydrogen called hydrocarbons. Hydrocarbons are differentiated as saturated and unsaturated carbon compounds. Saturated are made up of single bond. They are highly stable, less reactive, and all bonds are completely formed. And it is completely filled with hydrogen, and they are less reactive as they are very stable. And now alkenes, triple bond hydrocarbons are called alkynes. If it is single bond, then it is saturated, and those compounds are called. It is found only in the alkanes, that is methane. Only one carbon element is methane. And next, alkane starts with eth, prop, but, pent, hex, hepta, octa, nana, and deca. Thus, these names is common for alkanes, alkenes, and alkynes, with single bond, with double bond, with triple bond, except methane. Only carbon element is only methane. And even there is a general formula for alkane CnH2n plus 2, for alkene CnH2n, for alkyne CnH2n minus 2. In the same way, there is other type of a group called cycloalkanes. Cycloalkanes are closed structures with single bond, and these have a general formula called CnH2n, same like alkene. But the difference is alkene showing double bond and they are open structures. But cycloalkanes are made up of single bond but they show closed ring structures. There is other type of compounds called aromatic hydrocarbons. One such example is benzene. What is the molecular formula for benzene? C6H6. And some more examples, toluene, naphthalene are also example for aromatic hydrocarbons. And in the hydrocarbons we have a general concept called homologous series. Where there is a general formula, they have homologous series where each element, the above and below element, is differentiated with CH2. CH2, one carbon and two hydrogen. For each and every element, the variation goes with one carbon and two hydrogen elements. That is CH2. Variation is CH2. Homologous series is found both in alkanes, alkenes, alkynes, and also cycloalkanes. Okay, clear all of you? All of you cleared? Because in evening again we'll have the network problem. I don't know how far it supports. Now to you all having, few people are having the problem. The voice is not clear. And many they have good network and still they are able to hear me, right? But I am going very fast. Good. So many people. Our next concept is functional group. Now, the hydrocarbons in the place of hydrogen, if it is attached to some other, is called chlorine is attached, then the name is like this: haloalkane. The name is like haloalkanes. I'll just give an example. If chlorine is attached to propane, then we can call it as chloropropane. Now, the question is, when halogens are the functional group, then where the name halogen is added, either it is a prefix or suffix. This is very important because only in halogens it is different and rest it is different. Okay, I'll repeat once again. When hydrocarbons attached with the halogen, while naming where you are going to add the halogen, either in a prefix side or suffix side. Prefix means front, suffix means end. Yeah, Priyanka answered correctly. It is prefix. Because when we add the name at the starting, it is called prefix. When you add at the end, it is called suffix. Chloropropane, that is names comes at the initial stage, hence it is called prefix. Only here we can put at the front. And there is one more functional group called, what is the functional group of alcohol? OH. OH one example. If OH is added to then it is called ethanol, propanol, butanol, pentanol, hexanol, heptanol, octanol, nanol, decanol. These are the alcohols. And in the same way, aldehydes. Aldehydes ends with the letters Al. Al. Example is propanol. Ends. If it is CHO is added, the methane, only one carbon should be there, then it is called methanol. If there is only 2 carbon, ethanol. If it is only 3 carbon, propanol. If it is 4, butanol, al. If it is 5, pentanol, and so on. And the same way, there is one more. And what is the functional group of aldehydes? It is CHO. And that C is also counted. Remember, CHO, C is also counted for naming. Next, ketone ends with suffix ONE and with the functional group C double bond O. Now, if it is starting from meth, then methanon. If it is with ethanon, propanon, butanon, pentanon. Okay. So, in these compounds, C double bond O should be there. Then you can name it as ketones. The other functional group is carboxylic acid. The suffix is oic acid, OIC acid, oic acid. And the naming goes like this. The carbon is also counted in COOH functional group. That carbon is also counted. The functional group is COOH and that carbon is also counted like aldehydes. Okay. Okay, I'll start naming. Methanoic acid, ethanoic acid, propanoic acid, butanoic acid, pentanoic acid, and so on. Okay, that carbon is also counted. And next is, we all know that alkenes represented with double bond, alkynes represented with triple bond. In your examination, any example may be given. The pencil paper work, rough work, you just write in a pencil the structure and then you try to name it. Then definitely you don't lose. Okay. Go with the properties of hydrocarbons or carbon compounds. Carbon compounds undergo combustion in presence of oxygen to form respective oxides with the release of heat and light. Example, carbon combines with oxygen to form carbon dioxide. Methane combines with oxygen to form carbon dioxide and water. And ethanol combines with oxygen to form carbon dioxide and water. These are the examples for combustion. In this, the application level questions goes with the color of the flame. If the flame is yellow with lots of black smoke, then it is incomplete combustion. If the color is blue and with less black smoke, then it is complete combustion. So this may be asked as an application question where what is the indication of complete combustion and what is the indication of incomplete combustion. Blue flame indicates clean combustion with less black smoke. Yellow flame indicates incomplete combustion with black smoke. Okay, cleared? Cleared with combustion? This is the area where the questions may arise. Yeah, red or yellow, both are correct. Yeah, red is also correct, yellow is also correct for incomplete combustion. Okay, next is addition reaction. Addition reaction is applied to convert oils into fat. Remember, addition reaction is applied to palladium converts into saturated hydrocarbons. I repeat, unsaturated. Okay, battery is going very less. Unsaturated hydrocarbon in presence of catalyst palladium or nickel to form saturated hydrocarbon is called addition reaction, where oils or unsaturated oil is converted into saturated fat. What is the use of addition reaction? It increases the lifespan of the fats, and the fats are less reactive compared to the oils, and it increases the shelf life of the oil. And the next reaction is substitution reaction, where when methane undergo a chemical reaction with the chlorine in presence of sunlight, it easily undergo substitution reaction. You all know that for each and every step, one chlorine is added and one hydrogen is removed till it forms carbon tetrachloride. Carbon tetrachloride. Completely hydrogen is replaced with chlorine, and that is called carbon tetrachloride in presence of sunlight. I don't go with each and every step. It is already done. Okay. And the next concept is ethanol, and it is poisonous. It can be consumed, whereas ethanol in certain proportion, when it is diluted, it can be consumed. Ethanol is commonly called how ethanol reacts with sodium. Ethanol reacts with sodium to form sodium ethoxide. And when ethanol heated in concentrated sulfuric acid, then ethene is formed. Remember these 2 points. Be biofuel. Ethanol is a better. Ethanol can be replaced as a fuel. Methanol is a poisonous. It affects an optic nerve, causing blindness. It cannot be consumed. Okay, this about ethanol. And the next one is ethanoic acid. Ethanoic acid, acetic acid is both one and the same. Ethanoic acid is commonly called acetic acid. And 5 to 8% of diluted acetic acid is called vinegar. 5 to 8% diluted acetic is called vinegar. Okay, cleared all of you? And when ethanoic acid is freezes, it is called glacial acetic acid. When it freezes, it is called glacial acetic acid. Now, very important concept is esterification. What is esterification? When carboxylic acid like ethanoic acid reacts with ethanol, absolute ethanol, and then esters are of acid, it forms esters. This process is called esterification. Converted back to alcohol and sodium salt is known as converted back to alcohol and sodium salt, and that is called saponification. Okay, these are the two. And next to last concept is soaps and detergents. Soaps and detergents are used in order to remove the dirt from the clothes. And how the dirt is removed from the clothes? By applying the soap and by treating with the detergents. Which is strong? Detergents are strong. Which is weak? Soaps are weak. Soaps are made up of completely vegetable oil, whereas detergents are made up of acids. Since they are soaps are weak. Which is polluting? Detergents are polluting. Okay? Action wise, detergents are very active even in hard water, but soaps are not active in hard water. But soaps are eco-friendly, whereas detergents are polluting. Now, how the soaps, when soaps applied on the dirt, the soaps forms a molecule, soap molecule, which is having two ends, hydrophilic end, hydrophobic end. All hydrophobic end attaches to the grease, forms the micelles. So which part of the attaches to the grease and removes the dirt molecule? This is how the soap removes the dirt. Okay, this completes carbon and its compounds. Okay, now left with periodic table. We all know that under periodic table the important questions is the average sum of first and third element is equal to the middle element is known as Dobryna's triad rule. And there is another rule called Newland's octave law. When elements are arranged in an increasing order of their atomic mass, the first element and the eighth element show similarities, where the eighth element is coming under first element. Just arrange the elements 1 to 7 and the eighth element comes below the first element. And this is known as Newland's octave law. So next is Mendeleev's law. What is Mendeleev's law says? When the elements are arranged according to their increasing order of their atomic mass, the properties of the elements are the periodic functions of their atomic mass is the Mendeleev's law. And here Mendeleev's named the vertical columns as groups and horizontal rows as periods. And the last law is modern periodic law. Modern periodic law is otherwise called Mosley's law. What is the modern periodic law? The properties of elements are the periodic function of their atomic number. And why the number came here? Nowhere. Even in Dobryna's law, Octave's law, Mendeleev's law, it is completely based on atomic mass. But Mosley introduced atomic elements. These mass are called isotopes, periodic functions of atomic number. This is the modern periodic table. And the modern periodic table shows 18 groups and 7 periods. All left side it is completely filled with metals. All right side it is completely filled with non-metals. In the center, somehow boron, silicon, germanium, arsenic, tellurium, polonium. These are the metalloids. Metalloids, which shows the properties of both metals and non-metals. You can look at page number 30. Very clearly it indicates all green boxes are called metals and all yellow boxes are called non-metals and pink boxes are called metalloids. Okay, and next is trends in periodic table. So the important trends are valency. Valence electrons present in outermost shell is the valency. The combining capacity of the elements is the valency. Next is atomic size. Atomic size refers to radius of the atom. The atomic size decreases along the period, increases down the group. And next is metallic and non-metallic properties. Metallic properties, that is losing of the electrons. Non-metallic properties, gaining of the electrons. So the metallic properties. So this about the periodic table and its trends. The metallic character decreases along the period, increases down the group, whereas non-metallic character increases across the period, decrease down the group. This about periodic table, and this completes the chemistry of second semester, and I hope it was